Right. Morning. Welcome to. Okay. Okay. So yeah, welcome first of all. Thanks for watching. If you are new and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. I usually stream around this time each week working on something related to CircuitPython, although we do occasionally stray outside of CircuitPython as well. If you don't know what CircuitPython is, you can learn more about it at the main website here, circuitpython.org. It is basically a version of Python that runs on tiny computers called microcontrollers. You typically will plug these into your computer with a USB cable. It shows up like a thumb drive. You can edit a Python code file on there, and when you save it, the microcontroller will execute that code for you. I do have a Fruit Jam hooked up today again, so it's got a USB-C cable that's plugged into my computer. This one has a bunch of built-in stuff like this DVI port with an HDMI plug right here. I have this plugged into a capture card so we can see it inside of the computer here. But everything that I am running and showing inside of VLC here is running on this Fruit Jam microcontroller, which is based on the RP2350. So yeah, if you want to learn more about CircuitPython, you can at circuitpython.org. That was a very, very quick version. If you have questions, feel free to drop them in the chat as well if you see this. I'm happy to answer questions while I'm working on stuff. Thank you to Adafruit. Adafruit is a hardware and software company that is based out of New York. They make CircuitPython possible by paying a team of folks, including myself, to work on the project. And they're beyond CircuitPython, there's other open source software that they pay people to work on as well. So there's Arduino stuff and drivers and all kinds of different things. So thank you to them for doing that, first of all. And then if you want to help support CircuitPython and the rest of the open source work that they fund, one of the easiest ways to do it is by purchasing hardware from them at their website, which you can do at adafruit.com. And there is still a little bit of time left if you want to try to get the 15% off for the items that are in the holiday list there. So I have been doing a little bit of Advent of Code off the stream, and it's got me in sort of the somewhat festive-ish mood, and it got me thinking about ways that we could do something a little bit festive, at least on CircuitPython. And what I decided that we're going to try right now is Snowflake Maker. So we have the docs actually pulled up right here. In fact, we have, if you are at all familiar with Displayio, then you'll be familiar at least a little bit with the name tile grid, which is an object that you use to show something on the display. You attach a bitmap to it. You attach a pixel shader, which is like a palette or a color converter or other object that ultimately just gives it colors based on indexes. And then you can add that tile grid into a group, which you can then show on the display by setting it as the root group. On tile grid, we have these properties flip X and flip Y, which I believe will just sort of mirror whatever's in the tile grid, either across the X-axis or across the Y-axis. Not like the center of it, but I think the whole thing. So what I'm imagining is we make the screen essentially a square. We cut it into fourths. We have kind of like an X, right? So we have 1/4 of a square up here. We can draw whatever we want in there. And then we can flip to get it over here, and then we can flip to get it down here and down here as well. And then when we have all four together, I think it will let us make snowflake-like shapes. Almost like if you ever made snowflakes by folding up a sheet of paper and then cutting parts off of it, and then unfolding it, I think that is like essentially what we're going to end up with. Although it is an adventure, I have not done it yet, so possibly my guess is wrong. So we'll see how it goes, but let's get started by just getting the group and the display itself so that we can show stuff on it. Let's go ahead and set it right now. And we want to, I think I'm going to just use, let me actually do this while I'm thinking about it. So this will make it actually square for us. This thing is actually displaying a 4:3 aspect ratio. And we have a display that is, I currently have it set to 320 by 320. We'd go bigger? Should we go bigger? Let's test the theory at this size, and if the theory works, we can try the bigger size and see if it's like super slow or something. I don't know. I think it might be fine. I'm not sure, but so we have 320 by 240 is the pixel resolution that this display sees itself as. It does get doubled before it gets sent out, but we don't care about that too much here. So I do think that I would like to at least start with a square for my snowflake. So I'm going to use 240 by 240. We'll do essentially the center square of the screen. So if we have a total size of 240 by 240, that means that 1/4 of our snowflake is 120 by 120. So I'm going to say top left bitmap equals a bitmap that's 120 by 120. I only have in mind concept of using 2 colors. Maybe at some point we go through and add something more fancy, but for now I think 2 colors is fine. We will make a palette as well. That is 2 colors, so I will do 0 as, I'm gonna call 0 the background color, and I want it to be like a dark blue. So maybe something like this. Not sure how that will come out, but let's see. And then I do want the foreground color to be white. Is that right? Yeah, I think that's right. And then what we will do is in the top left bitmap, I will fill it with white. One second, I'll be right back. Okay. So we'll fill it with white, and then what we're going to do is subtract some sections of white, or I mean, really, we're going to draw blue over them, I guess is more correct ultimately, but and then we'll do the flipping and stuff as well. Let's make sure that we can get our white thing on the screen though, just make sure this is all working. So we do need a tile grid. And one thing is actually, we don't really need to call this top left, actually. This is just going to be snowflake. Because we're going to use 1 single bitmap and 4 tile grids. We're going to have top left tile grid. You can put that in the group, and then okay, white square, perfect. We'll worry about centering it in a little while as well. But for now, I'm just going to leave it where it's at. So, and we don't see any of the blue. Right now we have black background. The blue would be the alternative to the white, but the thing is filled. So let's start by trying to like maybe cut a corner out up here. And I'm pretty sure we can do this by saying map tools.draw polygon. I think, does this thing fill? I think it fills, hopefully. Otherwise we're gonna have to do something else afterwards, but let's try this. So draw polygon. It takes a bitmap, so that is Snowflake. It takes a right, yeah, this thing does this. So it needs, what is it? Like a list of X's and Y's, but are they're numbers or the list of points? Oh, this is vector IO. I'm in the wrong place. Hold on. Different way to draw a polygon. Y's, which are bytes. List of bytes. I mean, a bytes. I don't know. Whatever it is, byte array, byte list. I'm not sure, but it is just numbers inside of a list inside of bytes. So it is a little annoying, I guess. I want to have them as points first, honestly. So I want points equals. Points is going to be a list of tuples, which we're going to have 0, 0, because I want the top left corner. I want maybe like, I don't know, 40. Well, we're 120. Yeah, that's like a third of the way in. Let's do that. Like 40, 0, and then like 0, 40. That should be a triangle. And then we need to split those because this wants them in the other format, right? So let's say def it, let's say the def split points. Throwing this name. And we need two things. So x's equals, I'm just gonna make it a list to start, and then y's is a list, and then for point and points, yeah, pretty much this, and then we will return those, but we will bytes them first. We get back bytes, and then we can get those straight into here. And this is also going to be mad about shadowing because I'm about to use this name. So that. X's, Y's equals split points, and then draw a polygon. X's, Y's. Value. So we want value 0, and then close. None is true. I'm pretty sure we want true anyway. I'm just going to leave it like that. So let's see what that does. Oh, it doesn't fill. That's a bummer. Okay. I'm thinking of that fills. Maybe vector IO one does. Okay, no problem. We can still do this though, because we can, afterwards, we can go bitmap tools dot boundary fill, Snowflake, and we need a point that's inside of those. I'm just gonna hard code 1, 1 right now because I know that that is inside. X, Y. At some point we'll have to figure out, surely there's an algorithm for like given a set of points, find a point that's inside the polygon that they make. And I don't really need a specific point inside the polygon. I just need any of them, any point that's guaranteed to be inside. So the fill color, that's going to be 0, and the replaced color, that's going to be 1. Because we want to fill in white with blue. We're ultimately trying to subtract white. This effort. There we go. Okay, so we have a corner cut out. And now let's just make sure that the flipping thing is going to work how I imagined, because that's key to the rest of the snowflake making process. Right, like, and we'll do them one at a time. So this one, top right, flip X, true. And also X equals, say this dot X plus because that's going to be dynamic. If we change any of these later, this is going to allow it to still go over there without us having to come back and update the pixels. Nice. Okay. Yeah, so let's make sure, let's do the bottom two. Bottom. Yeah, I guess we could do right first. Well, I'm just going to do them at the same time, though. So bottom, left. So bottom left is going to have only flip Y, and it's going to be at... X is going to be 0, actually, but Y is going to be top left, Y plus tile height. Group, and then this one is going to have both. So flip X, flip Y. X is that, and Y is this. Okay. Both of those. Okay, perfect. We have all 4 sides mirrored now. And essentially whatever we do, anything we do in here, we can kind of like cut out parts of our white, which will then get rotated around. I'm going to move this up. This too many. We're going to keep the blank lines, although I am going to put this here. Okay, so let's yeah, let's cut some more things out. Actually, let's So I also want to relatively quickly get to the point where I am controlling this with a mouse rather than just hard coding polygons to cut out. So maybe we just go ahead and do the mouse now. And I also, well, yeah, I think let's get the mouse in now, because the concept is definitely going to work. This is kind of a boring snowflake, but I'm pretty sure the concept is going to work based on this. Get a mouse placed here. Well, we need to put it in the group. It's the last thing because we want it on top. I am gonna have currently a keyboard mouse combo plugged in, but I feel like this is probably a better thing for an. Oh, sorry. That so that I can move around. And really what I want is the mouse to be locked onto the top left tile grid. I don't want it to move outside top left tile grid. So I'm actually gonna, and it will already lock on the top and the left, which is convenient, so we don't have to worry about that. But we need to make it lock like here in the center and not go any farther, and then here in the center vertically and not go any farther. And I think we can just say mouse.x equals the minimum of mouse.x and would be just the, well, I'm going to do a little bit of dynamic here to make it so, again, if we end up changing the size and position, this will still sort of just work. Instead of hard coding it, we could just put 120, I think, and it would basically do what we want. But I think we could say top left tile grid.x plus the width of it. And then the same thing for y. What's up, Yano? Yes, hope you're doing well as well. I am. Yeah, doing good. Starting to warm up a little bit again. We had some super cold days and then snow, but getting a bit better. Let's see. We'll put this dot y should be height. Yeah, basically that would keep it stuck on that top quadrant. Yeah, so now we kind of have this like invisible force field that won't let us go outside of here. If I click, those clicks come through, so that's good. So let's set up a little bit more here. I want a click cooldown. And yeah, we'll just do half a second is fine. And we might as well also make a last click time is currently never. Setting one. We're gonna want to import time. Okay. So I want to be able to basically draw polygons dynamically. And one thing we're going to need to do is close true. We need to know if the user, like, I want the user to be able to click the points that they want for the polygon. And then when they click the first point again, that's when it should close. That's when it should like take action. But I do need to know when they click that point again, and I don't want them to have to click like literally exactly 100% on the correct pixel, we're going to give them a little bit of like, if they click within a couple of pixels, then we're going to count it as that. And in order to do that, we need to know the distance between 2 points. Which mathematics can tell us. By doing what this said before I clicked. Is right. Does it matter if one of them is bigger or smaller? Points is typically calculated using this, which is from Pythagorean. No, if I don't. So we're subtracting. We could end up with negative. Of course, if we square a negative, we're going to get back to positive anyway, so I don't think it matters, actually. Okay, so it's kind of absolute-y. Okay, so that's easy enough. I'm going to make a function for that, just so we have def distance, let's just say point A, point B, I don't know, maybe that would work, but it's definitely different than what's written here because there's no square root, right? We have that? We should, right? What was it? Math dots. Yeah. Square root of x squared minus, no, x1 minus y1, so maybe we should kind of just like point. We could go and say x1, yeah, we could do this actually, this would be nice. Then we could fill these in like this. That looks a little closer. Okay, so subtract them, power of 2 them, add that together with the y1, and then square root the whole thing, and that should be giving us the distance. Okay. So if they left-clicked, yeah, left-clicked, normal-clicked, they left-clicked, then we want to know the location they clicked, and we want to basically put a point there. So what I will do is, let's just say clicked points is a list. And when they click, we are going to so first we're going to say if the length of clicked points is equal to 0, then we know that this is the first point they're clicking. We are just going to go ahead and append point they clicked on. So that will take care of the first one. And we can also just, well, not break, but continue that, because we don't want to do anything else with this click. I'm also going to come back and do the cooldown in a minute as well, because it's going to click kind of fast, I think. Decided to do it now instead. So let's say now is that, and so then we're going to say if left click, so we're going to say if they did click, and if now is, yeah, that'll, it's kind of backwards from what I was thinking, but that'll work. So now, no, it's backwards actually. Yeah, I'm just going to redo it the way I think. So if now is greater than, yeah, this is more how. So last click time plus the cooldown. Yeah. And we'll just say greater equals. That way they could do it right on the nose if they happen to. So we ignore any clicks that are within the cooldown of the last click. We need to also set the last click to now if they are clicking. I'll move this in here so we only see prints for the ones that are not ignored. That's going to filter out like it repeatedly, I think, registering, because I think it might just keep going. I'm not sure. All right, so the first one's in. So then if we get to here, we know that it's not the first one. So what we're going to do is check if it is close to, check if it is the same as the first one. And for my case, I'm going to say if the distance between, it'd be nice to have the clicked point equals, I'm going to actually say current clicked point just to be super clear that it's not necessarily associated with that list just yet. So the current clicked point is this. In fact, we could just put this here and then do this here. What? What? But if the distance between the current clicked point and the first point in the list of all the points that they have clicked, so if they clicked on the first point again, well, if the distance between those two is less than, I don't know, 10? Not sure how long that's going to be really, but let's call it that for now. Then in that case, we do not want to append the point because the way the polygon thing works, you don't actually have to put that one again. It will that's what the close true, I think, did for us. We have, oops, split points, clicked points. Okay, we're also now, we are also now to the point where we really do need to know, we need to be able to reliably get a point that is inside of a polygon. Find a point that is inside of a polygon. Aid of given. I don't want to determine. I want to just get one. I want to like check a bunch and find one. Maybe we don't have a choice. They're all about determining, I guess. Okay. What if we tried Python? Their polygon is just a point. Do make it, it is a point object from somewhere. Well, they created a point object. I don't think this is doing the line thing. This is not doing that ray projection one. This is actually checking it compared to every edge. Be fine, I guess. Ray tracing. I want to use this. We can't use numbo, whatever that is. I don't really want to use numpy either if I can avoid it for now. Maybe. We'll this very quickly and easily for us. Find out. I think I had this for when we were doing collisions. I did like circles intersected polygons and polygons intersected. I did all kinds of different collisions, but I know exactly where that code is at this point. Function determine if a given point is inside of a given polygon. Polygon is given as a list of points. Use a ray trace. Use I or any other. Is it pure Python maybe? I think I figured it out. Let's read this real fast. All right, so have a single point, xy. We have a polygon given as a list of points. We have number of vertices is like what that other algorithm said. Inside starts as false. Iterate through each edge. We're going to say one end of the edge, the other end of the edge. So each edge is defined by 2 points that make up the line. Range in number of edges. So we go from 1 to 1 plus the number of edges. We get another, we're going to be checking each edge here essentially. So we have one edge where we're getting another one based on I. So we're getting each edge iteratively. Check if the point is within the Y bounds of this edge. Calculate the x intersection of the ray with the edge. They're not equal. The edge is vertical or a point on the left, then toggle. Not inside. And then here it does essentially advance to the next point. So take this, or not point, but edge. Take this edge and put it in this one, so that next time around we're comparing with the previous one always. Okay. Yeah, that sounds like what Wikipedia said. For the lines and then like flopping back and forth if we pass. Okay, so yeah. Polygon. So I'm gonna make now a find point. Find inner point. Find point in polygon. This one is only going to take the polygon, and its job is going to be to find any point that's inside the polygon. We just need one. So, and I am going to try to keep it relatively simple and just sort of like spiral outwards from one of the points in the polygon. So a vertex is polygon 0. So that's a point. That's one vertex. That's one vertex of our polygon. And then what we're going to do is we're going to check the 8 pixels that surround that. This might not cover all cases, but I'm going to start with this. I think if we just do this a couple of times, like maybe we do the 8 pixels, and then if we have to, we could do the next outer rung or whatever. But I'm pretty sure if we just check pixels around the points, we should find one that's inside. Point, so check those. So we're gonna say checking point is a vertex plus x, so shift it by the amount we're checking. Check if it's inside. If that point is inside the polygon, then return that point that we're checking. If we make it to here, just return none for now. We could go down the list, the rest of the points, I guess. The only thing is, like, if the angles are acute enough, like, we are still in a bitmap world with a 2-dimensional grid of pixels. So, like, if the angles are acute enough, then technically the line, like, you'll have to go farther away from the vertex, essentially. We could try something else, like the halfway point between the midway point between all of the lines, if that's a thing. I don't know. We'll start with this. Hopefully this will be good for a lot of different shapes. Okay, so yeah, we're back down to clicking now. So we have clicked, we're adding points. Well, so we haven't actually added any. We added the first point so far. We're going to add more, but I'm going to kind of do this out of order. We're going to worry about what happens when we close the polygon. So we split our clicked points, we draw the polygon, and then next we are going to find a point that's inside of it. So inner point equals find a point in the polygon. Polygon is clicked points. and then we are gonna fill the boundary fill on the inner point 0. Inner point. I do think there's going to be cases where this logic doesn't work, but I think if we keep them to like sort of regular-ish shapes, it should be okay for now. So that's the last one. So else if the distance was further away than 10, if they're not closing the polygon, then all we really want to do is just add the current point to the clicked points. Now there's no visual feedback. It would be nice to have, but I think we should have enough to at least try it, I think. Or see why it crashes. If I do something like, I'm going to click this corner first so that it's easy to get back to. I'm going to go out here, click this, I'm going to go down here and click this, and then I'm going to go out here. Boom, look at that. Okay. Okay. We could also, I'll do this corner as well. Click this corner. Over here. Click out here. Here. Click here. There. There. Come back. Oh, it didn't work. Okay. Oh, you know what I didn't do? We need to empty the clicked points. I'm surprised that didn't... Oh, because we're not clicking that again. Yeah. Okay, that makes sense, actually. Whenever they close the polygon, we also need to clicked points... Clear all those points out, because they're starting a new polygon now. So let's do one down here. So... bottom corner there, and I will go a little crazy again, so we just kind of just clicking around. There, and then we'll go back here. Nice, look at that. Okay, that's sweet. That is super cool. Okay, so then doing out here as well. So let's do that. There, 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 there. There. Over there. Okay, yeah, this is totally going to work. Let's get some feedback for where we're clicking. Get some feedback. Why don't we... I mean, would it be bad to just drop a point on the bitmap? Like change a pixel in the bitmap? We're going to draw over those points anyway with the color that we're using. I mean, that's certainly a simple way to do it. So let's start there. So let's say Snowflake bitmap mouse oh well, we have clicked point, cur clicked point. So we want it to go back to blue. The first one is there. The rest of them are here. And then that one will do the fill in. So that will let us see what we're doing. Let's see if I can do one in the middle now. Click here. That's my first one there. Go back to the first one. Nice. Did do a little, there is like a little white pixel here. But pretty good nonetheless. And we should be able to like just kind of run into this one as well, I think. So we can just click here up inside that one. That should be no problem as well. Well, what happened with this bit right out here? Or do I know why that's filling in when I mouse over it? That's very bizarre. Does this do that? That. Oh. Oh, I think I did well, I didn't hard code 120, but I think this is gonna put it to 120. We actually want a -1 as well. I don't know why that worked before. I guess I wasn't in the corner. Like, oh. Okay, see there the fill did not work. Let's just expand the search a little bit, actually. Instead of worrying about trying to like spiral or whatever, let's just go ahead and expand the search. So let's say instead of the 8 pixels immediately around it, let's do like 3 layers of pixels. I think that should hopefully get the vast majority of cases, because we only have 120 by 120. Maybe we scale up and we have then 240 by 240, but it's still like not that big of a grid. So we shouldn't have shapes that are like super extreme flat line to flat line, I don't think. We could check other vertexes as well if we needed. Let's say -3, and we want to get to, well, I guess we could just say, would it be 3 higher? Would it be 5? Be -3, 0, 1, 2, 3. This would actually be 4. Right? Because we'd have -3, so -3, -2, -1. Technically it's going to check 0 as well, which is the vertex, which we know is not necessarily inside or outside. Hopefully this function returns false for it. Hopefully. We could, like, if not 0, 0, I guess, if we really need to. And then we want 1, 2, 3 as well on the other side. I think that's right. There we go. Freaking sweet. It might be interesting to have a mode where you don't see the full thing. Or like you could switch back and forth or something. Where like it would make just the quadrant you're working on bigger. And it would let you see only it until you like click a button or something. We could use the other mouse button maybe. Follow this, and I think it'll make a neat thing. Failed again. Why would that have failed? That might be, I think that maybe that is treating 0, 0 as inside. Because we do not actually want zeros. We do not want to boundary fill on the line exactly. We need to boundary fill at least 1 pixel in. But it would have started from like up here and moved this way. I'm surprised it didn't fill outside. Well, it can't, well, it wouldn't fill outside because it would have been false, I guess. Hmm. I'm assuming it filled on the line. All right, let's try something so that we can see what's going on. So we'll make a 2 with red, and then what we'll do is, instead of actually doing, or maybe in addition to doing the boundary fill, so after the boundary fill, maybe we just also go Snowflake bitmap inner point 2 to turn that red. So I want to try again with a point that starts on the left wall. I think that maybe that will the key to getting this to reproduce. We're gonna snap this just so we can kind of refer back to it. Get rid of those left prints. Those are not very helpful at this point. There. Didn't turn red. Oh, I don't think I set the number of colors. That will need to be 3. And also this will need to be 3. Actually, I'm surprised that didn't raise an exception. Okay, yeah, it is totally on the line. Okay, new plan. New plan, new plan. When we find an inner point, we only use it if it is white in the bitmap. So if Snowflake bitmap checking point, it needs to be 1 to count as an inner point. There we go. I think that will make it be okay. I'm going to turn off the red dot for now. I mean, we might as well turn this print off if it's gonna, like, if we printed the location or something as well. I mean, we have visual indicator now, so need to print the location. Something like this. So here, there, this way, and then up this way, and then there. Up that way, and then here, here, and then there. Did that fail? Turn the thing off also. Okay. I think new plan. Instead of checking around a vertex and trying to find... Instead of checking around a vertex and trying to find one that's inside... Boy, I don't know why that would have failed, though. You know what I should have it doing is printing the points when it does this. So that we could theoretically like redo the same shape by copying it back in instead of having to click. Or why it wouldn't have worked. It's kind of close to what I did the first. Fine. So I didn't do the whole wall on the left, I guess. I had only a point. One thing I'm thinking, though, is what if instead of searching around vertexes, what if we instead found the midway point between every vertex? So we basically go through the list of vertexes. We take 2 vertexes at a time. We find the midway point between them. And then we check that if it's inside or outside. Because, like, this one, it would have checked, you know, like, eventually, like, this point, and halfway between them is here. So some of them wouldn't work. Like, this one and this one, halfway between them is out here, but our function should be able to tell us that. We could skip, like, we don't really need to test each point against its neighbors. But we do kind of want to test each point against every other point if we go that route. I don't really know, though, why... Oh, and this is like... Oh, wait, no, it's not. Okay. It's like... Wait, did that... It wasn't... Oh, I haven't saved. Okay. But I don't really see why this one didn't work. I wish I would not have turned off the red, huh? Touch the top also? I mean, it's not the exact same shape. I'm not going to be able to get it exact same, but pretty close, and it's basically... I guess let's just keep playing with it and see if I can get it to do the thing again. I don't really know. Nice. Well, and if it's only a triangle, actually, we have a problem with that other algorithm, right? We can't really do halfway between each point if it's a triangle because it's only 3 points, which means halfway between each point is always on a line. I mean, if it's a triangle, there's probably a formula for the center of a triangle. Really know what to do to try to fix it if I can't get it to happen again. I don't really know how to get it to happen. I don't quite understand what caused it the first time. It's interesting how these don't... Oh. Interesting. I feel like the refresh is not working right. Because it had that white line in the middle before I moused over it, and then when I moused over it, it caused it to refresh better. Presumably, I could do the same to that one, except for my mouse is locked over here, so I can't actually. Yeah, same thing here. That's interesting. I don't even really know. I'm not even really sure what to do to try to fix that. I could try. Force a refresh? I don't know. Oh. Yeah, we can't do that because the mouse needs to move. I mean, I guess we could try to force a refresh with auto refresh on anyway, but that happen on every edge? Oh, that one was not the easiest one to check, was it? But it seems like it happens only on the bottom. Seems like it happens only on the bottom and the right. Which makes me think that it's like an off by one error somewhere, but I don't understand why driving the mouse over it would fix it, really. It definitely does. Oh, I don't remember where I started. Oh. Oh, we finally returned none from that thing. So because I kept clicking inside blues, we did finally return none. Hmm. Yeah. So that's tricky basically because basically I did manage to click near where I started, so that's good. But because I clicked in other shapes every time, none of the points around the vertex were counted as inside. Probably because of the extra check we added for the color to be white. One kind of looks like a mouse cursor. I didn't notice that until now. One here. You know, 4 of them, but rotated. Hmm. We could actually do some cool stuff with outline, the thing that I worked on yesterday. If we did the polygons, like, if we let them not fill, so we had unfilled ones, we could then run outline on it, and it would add like color, kind of like make a thicker border. But we could then, I think we could keep stacking outlines. Like next we could outline the outline color with a different color. Does that just keep working? Or would it overwrite the other one? It might overwrite the inner one, actually. It might overwrite, I'm not sure. The in-center or the centroid? I would like either the in-center or the centroid. In-circle. In-circle center? Oh, what that one? Find the centroid. So the centroid equals the x's all added together divided by 3 is the average of each point, right? The y's all added together divided by 3. Yeah. Okay. Okay. So I'm going to try the halfway things. Because that would help us solve the if they clicked inside of other shapes already. But we do need a special case for triangles because triangles only have 3 points. If we check the midway point between them all, we're always going to be on the lines. Comment this out. So if the number of points is 3, so if the length of polygon equals 3, we're going to do the centroid, which is we need to add, so polygon I'm going to go ahead and make x1. Go ahead and make all of these and then do plus 3 divided by 3. This is the centroid x, centroid y. Centroid, we should be fine to just use that, I think. So if it's a triangle, do that. If it is not a triangle, we're going to assume that it has more points than a triangle. We're not going to worry about what happens if they click a line for right now. That will probably crash or something. I don't know. For now, we're going to assume that it has at least 4 points. And what we're going to do is we want to find the halfway point between all the points, basically. Halfway point between 2 points. What? Oh. Geometry. Jesus, what is... Where to go and eat or something. Crazy. mean, it's this, you know, it's conceptually the same, but like I don't need GPS and like. Okay, midway point is what? Midpoint is an equation. Equation. Same thing, but only 2 points. Actually, it's literally the exact same thing, but it's only 2 points. Interesting. I mean, I guess that stands to reason, doesn't it? Does it? Okay, so for point and polygon, I'm gonna do this the naive way. Like, technically, we don't need to check the points that are. Well, okay, let's do this actually. Let's say for I in. I'm just gonna enumerate. It makes. Okay, I'm trying to like. I've learned that enumerate is slow. I'm trying to not use it, but then also trying to be like, boy, it is sure convenient, isn't it? We'll do this. This is, I guess, a little bit better. Okay, so we're looping over all the points. We get a point, and then what I want to do is basically we need to loop over all the points again. So I hesitate. I don't usually like to do ij, but say we're just going to do it again. Land polygon, that. And then what we're going to do is checking point equals polygon j. Yep. And then what we're going to do is, so first of all, if checking point is not equal to point, we don't need to check it against itself. That's not going to get us anywhere. Also, if, well, we could do this easier. We could say if I not equal j, because those are indexes within the polygon. The polygon's in the same order both times, right? So if I is not j, if we're not looking at the same point, also if j is not I plus 1 and j is not I minus 1. So we don't need any of the points that are touching this one. We want to check all the points that exist in the polygon that are not directly connected to this one. So we kind of want like opposite points, essentially. In the case of a square or a rectangle, it'd be opposite points because there's only one that's not touching. But you know, as we add more points, like a hexagon or something, you could choose sort of any of the opposite points, any of the points that aren't directly connected. Okay, so we do that. We say, if it's actually a point we care about, then find the midway point. So midway equals, I'm going to break these out again. Point midway equals midway. We could just do, I guess. So midway point we now have. And then finally we go if point polygon midway polygon. So if the midway point is inside, and we will also go ahead and say if it is a white pixel. Return it. Float to int 178. end up with a float this time. Might have ended up with a float this time. Okay, I'm just going to turn it to an int before we... Interesting is here, presumably it was also a float? I mean, we could... Oh, wait, hold on. Point. We should be, first of all, we should be returning midway, not checking point. Oh, well, this is not the, I'm doing the triangle case. Triangle case. Ah, there we go. Now the red dot is way in the middle there. Be able to do like this kind of thing, basically, which is what I was going for on the last attempt. It's like basically make a triangle on every edge. Fill that one in. That one worked. Okay, so then basically if we went like here, 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 back. Nice. Cool. Okay. And then this would make like not really a snowflake, right? Because the white is trapped on the inside. Well, other than the fact that we have these kind of things going on here, but like this section is all enclosed. So maybe not a real snowflake, but a cool shape nonetheless, sort of kaleidoscopy. Theoretically, you could be doing this with colors too. Like I'm filling it with just blue, but you could be doing like other colors, I think. Ooh. Yeah. Hmm. Oop, wrong mouse. Let's do. Yeah, I don't know what to do about those. I mean, it kind of implies if we draw over it, it will get fixed. Could just draw a full screen thing over top of it every time. Erase it real fast. All right, BRB. I'll be right back in a second. Reset. I think this USB cable that I am using is on the fritz, honestly. It's got some kinks in it that I think are, you jostle it, occasionally they cut the signal, essentially. I sat down, I jostled the desk just enough to make that happen. I think that I may actually wrap it up here. Basically made what I wanted to with this. It would be nice maybe to continue this and add a bit more features to it. I mean, we could get rid of the red eventually. I need to make sure that that issue is not going to pop back up, though, so I'm going to keep it for now in case it does. Yeah, I mean, it might. There's some other cool things we could do with it. As far as features, like maybe giving you an undo. Maybe that's going a bit far. I don't know if we need an undo. But maybe a save. You wanted to save one, be able to get access to it again later. That could be cool. Maybe trying the bigger display. And then maybe also what I was saying before is it might be cool if you had a mode where you were looking at only the top left quadrant. Like maybe what if I could right click? Like I would right click and it would take me to it would scale up by 2 the top. I think I just said top right a minute ago. I meant top left. So it would scale up the top left quadrant by 2. It would show you that. It would let you draw your stuff on it, and then whenever you right click again, then it would bring you back to this view here where it's flipped. So you kind of like, you can draw on a big version of the top left, and then you can click to see the rest of them. That might also, like, if we got lucky, then that might also just accidentally fix this problem by way of changing what's on the screen, basically. Might be worth it. So yeah, there are a couple of things that could be kind of cool to add to it, but the gist of this, the essence of this is essentially, like, this is exactly what I wanted to make, was this ability to kind of click around, draw random polygons, and then have them sort of get cut out of the white paper, which then unfolds across those axes. Same way you would do it with a piece of paper. And we have done that, which is pretty sweet, I think. So I am going to actually call it quits for now. I need to go mess with my car some more. I just checked on it when I was gone a minute ago, and it's got trying to charge the battery. And I think it says it's done, or else wants attention for some other reason. It's not doing the yellow like it was before. So I'm going to go look into that. Getting a slow start today, late night in the workshop. I got you. Yeah, nice. What's up, C. Grover? I'm headed out for now, so you can check the VOD if you want. But I do still have the last of my coffee, so cheers on that. I could throw this up. I don't know if anyone else wants to play with it. It's a fruit jam is what I've been doing it, so I'll just throw it up on Gist maybe if anyone wants to mess with that. Should go until you click it. Go. Drop the link there in the chat if anyone's interested in the code for that. Oh, the other thing I think would actually be pretty cool too, I was talking about it before, was maybe making a version. I mean, this is less of a snowflake and more of just like kind of getting more towards the kaleidoscope, I guess, but making a version where it does not fill the shapes. it leaves them unfilled, and then we play with that outline function that I was building yesterday for bitmap tools. So I think we could maybe, not sure if it would actually work out, but I think we might be able to end up with a situation where we could get like, you draw a shape and then you get a rainbow of like slightly larger, slightly larger, slightly larger, slightly larger, like going through the colors of the rainbow, which could look kind of cool, especially if it also does still flip. So that's another idea that maybe I'll play with as well. But that's it for now. Thanks for watching. Have a great weekend as well to you, Yano and C. Grover as well. I should be back, I think, for the normal streams next week. Deep dive on Friday. Can I have the calendar? Deep dive on Friday. Yeah, deep dive on Friday. I should be back on Saturday as well. And then I think the following week too, but then I'll probably be taking this week off, which I think I said last night as well. But we'll see for sure once I get a bit closer. But that's it for now. Thanks for hanging out. I will see you next time.